Okay, everybody, can we please take a look at this sheet? I have recapped the rules for you up at the top. So we just were talking about adding, subtracting, multiplying, dividing. Find domain, find the domain of each individual function and the new function. Where they all overlap is your final domain. Okay. So let's see. Could you do the first three down here? Just those first three. And then we'll talk about the composing functions again. So you do them and I'll do them and we'll see if we match. Give you another minute to finish these three. We'll see if we all match. I don't know. Maybe I shouldn't have shown you my answers. You did?
I did.
Oh, that's good. Okay, so let's talk about where these domains came from. So here I'm just adding the two together. All you have to do to figure out your final domain. So the domain of the f of x function, that's all reals. So no problems there. The domain of the g of x function has to be greater than or equal to 0, right? I just can't let it. So there was my f of x. Here's my g of x. So where they overlap is going to be my domain of f of x plus g of x. And where they would overlap, let me get my other color, would be all here. Okay, so there is my domain for my combined function. We're okay there? All right, let's look at the next one. I didn't leave myself a ton of room here, but that's okay. So I have another number line. 0. So let's see, f of x again is all reals, so that's nice and easy. G of x is greater than or equal to 0. But my new function, my combined one, involves a fraction. I can't ever let that denominator equal 0. So that means I cannot have 0 in my answer or in my domain. So when I combine all three of these, I want what works for all three of them. Over here only works for 2. Here doesn't work for all three, so you can't include 0. So I'm going to have an open circle at 0, but it does work for all three past that. So please double check that you have x has to be greater than 0. You can always sort of check yourself too. Say, okay, if I did plug in 0, would that work? No, right away you'd say, oops, that gets me a 0 in the denominator. Yeah, I definitely can't have 0 in. But I can plug in things bigger than 0. I can plug in 1 just fine. Try and plug in a negative. You'll see very quickly, oh, I cannot plug in -1 because I can't take its square root. Okay, so there's that one. And then the last one, a little trickier now. All right, let's see. We're doing g of x times g of x. So let's see. The g of x function cannot be negative. So I can have anything 0 or greater. My combined function is all reals. So where does it work for everybody? At 0 and above. Does that make sense? Are you with me? Everybody's okay? All right. So that is just a summary of what we had talked about the other day. We started composing functions, and let's revisit that now, okay? So if we look at the rules recap for composing functions, so that's when you're putting one function inside of another one. So remember, we have two different notations for that. You can either write it as f of g of x like this, or with that open circle in between them, they mean the exact same thing. Okay, so you got to just be able to flip-flop between the two. So here are the rules when you are composing functions to find the domain. You're going to take the domain of the innermost function. So in this example, if you're looking at it written either one of these ways, g would be the innermost function. It's the one you're starting with. So I always take the one closest to the x is the g. Here, the g is on the inside. So in either case, g in this, when it's written like this, is our innermost function. So I want the domain of the g function. And I want the domain of the new function. So I don't actually care about the domain of the f function in this scenario, because I'm not really dealing with it anymore. I'm taking that f function, I'm replacing parts of it. So I want the g, and I want my new function. I need to look at where those domains overlap, and that's going to be the domain of the whole thing. Okay, so let's try it down at the bottom here. So we're doing f of g of x. So first, what this means is take the g function and put it into the f. So I'm going to take the square root of x, which is the g function, and I'm going to put it into the f in place of x. So instead of writing x squared, I write square root of x squared. Just like that. So you need the parentheses here. It actually doesn't really matter. Yep. Yes. So if you simplify that, you just get x. Now let's find its domain. So I want the domain of the g function. What's the domain of the g function? Jake? Yes, there's my g function right there. My combined function is just x. So what's the domain of that? Jake? All reals. So for my final domain of this new function, I need where it works for both. So in this case, it's going to be from 0 and anything greater. So that would be my answer for the domain here. X has to be greater than or equal to 0. Okay, so you need the domain of the innermost function and the new function. Where does it work for both? That's your domain, your final domain. Okay, so now in this bottom one, oh geez Louise, you try the bottom one while I fix this. Oops. Okay, I'm still screen sharing, so hopefully it shows on. Okay. All right, so let's see how you did. This time I'm taking the F and I'm gonna put it into the G. So I want to take X squared and put it into the square root of X. What's that gonna give me? X, yes. Assuming that our X's are all positive here. I think that's the intention. Okay, so let's look at finding our domain. So whose domain do I have to worry about, F or G? Jake? F. This time it's F. It's the innermost one, so in this case F, and F's domain is all reals. What is G, my newly composed? What's the domain of that one? Jake? All reals. So domain of the whole thing, all reals. Yes.
So where this square root of like -1, when it's the -1, so for the f of x to be all real. It's like the square root of -1 is like irrational by itself, not real by itself, but you square it, then it becomes -1. So when it's all real.
No, well, no. Because in my G of X function, I can't plug in negatives. So I don't want to include them in my final domain. Does that make sense?
Yeah.
Okay. All right. How are we feeling? Better? Okay. So I think I have some more practice problems on the back. All right, give these a shot. I'll give you, oh, I don't know, 5-ish minutes. See if you can work through these ones. So again, you're gonna do the same thing. Do the combination that they're asking for and give me the new domain. While you're doing that, I'll see if I can get my gang together.
You would say mistake here. Oh, so that. Okay.
This picture is so funny. I don't remember doing that. What? I like that. Yeah, I do. I do. You don't be negative, bro. You're not gonna get it. the way she taught us. Her
I don't
son's
know,
all
why
real.
is it F plus G? So is the F of X plus the G of X?
I don't know, but it's the same thing.
It's not like.
Henry, you're so. For me, all real. It's all.
It's pretty fun.
Oh, yeah. All the time.
Alright.
Oh my God,
Yeah.
Miss Richie.
Angela?
Yes.
Is this Richie Sam?
Yes.
Wow.
They're good.
They get you?
They-
Well,
he
it
gets
really
it.
took them.
This
First
is
thing
not
I got.
the
Oh, these all Braylon's math teachers.
Yeah.
I said, I'm like, I want to drop him for a week so you guys can guess who I am on Friday.
Oh.
I said, this weather makes you want to curl up with a good book. That's
He goes,
it. And
"And
he'll
fill
fill
us."
us.
And you told him how many times?
after you
No, I didn't even say
Maybe
office.
15.
Maybe 15 times.
That's what I'm saying.
I don't know if I'd ever-
I don't know, but he had it. I'll be back.
Any character ever.
I haven't.
Yeah.
All right,
Well, thank you.
well, that's fine.
Yeah.
Okay. So all the people who have me for algebra 1, are all your algebra 1 skills coming into play for algebra 3, like I told you?
They are.
I don't remember anything I
Like,
learned.
yeah.
I'm sorry, Miss Richie.
What?
I don't remember anything I learned.
I do. I
Oh
saw
my
the
God.
Yeah, but I'm doing
I was
good.
like,
You're
wow.
gonna be very low.
You fell asleep.
You doing well? Oh, he did my
Yeah.
in this class?
Yeah. Brian fell asleep.
Right, yeah, what a winner.
Like, look where he is.
No comment.
Oh my God, that's so funny.
We did so good. It even says, you can't really read it, but on the door it says, do not disturb party planning committee meeting in progress.
He's not taking on number 3, right? Fran? All right, Miss
I don't think he's
G's
taking
gonna-
that.
Thank
I
you.
thought he was in computer
That
science.
is pretty good.
Anyways, we're pretty spot on, so.
Although,
I think, yeah. I mean, I thought it was pretty good.
I don't think Pam's hair is black.
Oh, well. We went with wavy. I'll see if I can find you Judge Judy real quick.
Oh, what's number 4?
Oh, here was, can you guess what we are this year? This was 2019, I
That
think.
is Hermione.
Harry Potter.
Yes, we were
Wow,
Harry
Henry.
Potter. Hold
The
on,
one
let
on the
me,
left, I'm gonna say is Snape.
why won't it, there we go. He's Snape, yep,
Dumbledore.
Dumbledore.
Oh, that really annoying professor that always wears the pink is Miss Swanson. I don't know.
Umbridge,
Yeah,
yes.
I'm gonna say you're Hermione.
No, I'm not Hermione.
Oh, right. Are you guys all professors?
That's a crystal ball in my hand.
Oh, she was the hippie teacher.
Yes, I'm Trelawney.
Who's the left?
Yes, I think so.
Dumbledore.
Oh, yeah, Miss Carboni was, she's got like leaves on her. She's rubbly plank, I think. And Dr. Escobar is Bellatrix. Yeah, that was a good year. We were pretty good. I forgot the video is still recording, but that's okay. Oh, this was cute. This was, we were the number pi, and so everybody was just another digit. That was, we got the most participation that year, because you literally just had to wear a number.
It's greater than or equal to 100.
Yeah. So it can't be wrong. Yes.
Do you want to see my son's first Halloween since I just found it? Look at this, I made him. Oh, where'd it go? Yeah, his like strollers on the inside.
That's actually pretty
It was so cool. And he had like an astronaut costume on. I was so proud. I was very extra that year. Oh, yeah. Oh, I have to show you this one, but I don't know how to rotate it.
Does this look about right?
For all of them? Or which one?
Yeah. It's like,
Oh
my God.
that's when I was pregnant. I was the
That's so
Thanksgiving
funny.
table.
Don't write on it with pen, I'll throw it.
This is not right. This is where you gotta, remember, you gotta split them up.
So
X squared minus 1 has to be greater than or equal to 0, right? So that means you're gonna, it's gonna
Oh,
like go
because then I
both
have to
ways.
do X plus 1 and X 1, okay. I'm not even know. What the that's just awkward. He's gonna know it's not me. I'm just not gonna say.
I can't find the ones of, that's Judy. Anyway, how did we do?
good.
Okay, let's take a look. So for the first one, we're just gonna add F and G together. Okay, good. So you should have had, let's see, x squared plus 2x minus 4 altogether. And what's my domain? Everybody, all reals for this one, no problems here. If we're gonna do F minus G, you're doing, I'll write it out here, you're gonna do 2x minus 3 minus all of G, not just the first term, all of it. So when you do that, you're gonna get 2x minus 3 minus x squared plus 1. So if you rewrite that nicely, that comes out to be a negative x squared plus 2x minus 2. Right? What's the domain this time? Jonas? Thank you. All reals on that one. Multiplying the f and the g together. Let's see, that's going to get us 2x cubed minus 2x minus 3x squared plus 3. Maybe swap these two if you want it in order. Domain. Everybody. All reals, yes. Now things get a little bit trickier because we have division. So we're going to do the f. 2x minus 3 divided by the g, x squared minus 1. So even though the domain of f is all reals and g is all reals, the domain of the final one is not, because I can't have a 0 in the denominator. So what must be excluded? One is correct, but there's something else.
Negative.
Negative one.
Yeah, positive and negative 1. So I'm actually going to write it as plus minus 1. Ah. All right, now we're doing our composition of functions down here. So for this one, I'm going to take h and I'm going to put it into the f. So let's try it. Take the h, put it into the f. So that'll be 2 square root of x minus 3. So far, so good? So what you need to consider is the domain of the which function, F or H? Which one do I care about? Jake? H. I care about H and I care about the domain of the final, this combined one. So if it helps you to do the number lines, go ahead. So I'll give myself a number line. Let's see. H has to be greater than or equal to 0. So there's H. The combined one, again, I have to be greater than or equal to 0. So that only makes sense that my final one has to be greater than or equal to 0. Was that all right? Okay, now let's try H of G of X. So I'm going to take the G and I'm going to put it into the H. Let's try it, putting the G in the H. Okay, which one do I care about? I care about G. So let's see, G is all reals. The combined function, however, there's a radical in there. Can you have radicals that go negative? No. So this is where a lot of you were messing up whenever we did that in the other chapter. So x squared, I'm going to do it over here. X squared minus 1 can't go negative, right? So it has to be greater than or equal to 0. And then a lot of you added the 1 to both sides and square rooted, and you basically ended up with something that just said x has to be greater than or equal to 1. But that's only half the answer. We talked about how when you have, so I could split this up, right, into x plus 1, x minus 1. Has to be greater than or equal to 0. When you have a product with an inequality, it doesn't really work like it does with an equal sign. So we talked about taking this and sort of splitting it up. So I have important values at -1 and a +1. Oh, I don't put 0, I don't know. And then remember we checked values in between. So let's see, could I have +1 and -1? Yes, I can. So I'll put solid dots at those. Could I have another number bigger than 1 and still keep this positive? So if I had 2, for example, yeah, it would still be positive, so I can have those. I'm going to take a number in between -1 and 1, like 0. If I plug in 0, it goes negative. I cannot have these values in between, but what a lot of people miss is I can have numbers back here, like -2. If you plug in -2, you're going to get a negative times a negative, which is a positive. So you can have these values. So the domain of the combined function is this. So I'm going to overlap that. I mean, the other one's all real, so it doesn't really matter, but whatever. 1 and -1. So I can have 1 or greater or -1 less than that. So if my final domain is going to be where these overlap, it's only going to be here and here. Does that make sense? Be careful. Look at what you put. So how do we write this? You need x is to be less than or equal to -1, or x is to be greater than or equal to +1. You should not have written this. You can't write that as one big block, like when we do ands, because there is no number that's less than -1 and greater than 1 at the same time. So you can't write it that way. Oh man, this is getting rough. Okay. Did we get that one right? Or if you didn't, do you know what to do now? Okay, let's try G of H of X. We're going to take H and put it in the G. Okay, so we'll take the square root of X and we're going to square it -1. So when I simplify that, I'm just going to get X minus 1. Let's find the domain. I need to worry about the domain of H and the combined function. So H has to be greater than or equal to 0. There's H. The combined, that's all reals. So what's my final answer? Boy, you guys are quiet for a Friday afternoon before Halloween. Aren't you jazzed up? You're not? I am. I can't wait. Oh, not 1, 0. What am I doing? There we go. There's my domain. Okay, one left here. We're gonna take G and we're gonna put it into H. G, oh, didn't we already do that? Oh, we did. Huh, we don't have to do it again. These are the same thing, aren't they? So hopefully you just put the same answer. So I'm not even gonna, same thing. Probably was supposed to be an F there or something, but whatever. Did you notice that was the same? Or did you do all the work again? Okay, anybody have any questions right now? We feel all right? We ready to get our homework done so we don't have any over the weekend?
Yes.
Oh, right. There you are.
Well, are we doing all of them?
Yes, there's only 8. Problems? That's it.
I'm not sure.